All right, so before Thanksgiving, we did chapter 14. And so I'll kind of review you on that in a second. But like we talked about, chapter 15 is going to be what's called conditional probability. And that's actually probably more of an occurrence than what we experienced, the simple types of probability before Thanksgiving. So that's really what's going to relate more to your real world stuff. Okay. So let's go. We're going to be working on that with Venn diagrams and a formula. So let's take a look at what your homework is going to be. So you'll actually, page 20 is notes. So that's not an assignment, but page 21 is the practice on Venn diagrams. And then the 24 to 26 is kind of all of that together. So that's what you're going to work on there. Now this is a thinking map, the tree map of some probability things that you have in your packet on page 7. So you could go here if you wanted to. But let's kind of talk about what we did before Thanksgiving and bridge into what we're doing today. So do you remember when we would have problems where it would say something like, what's the probability that the car is American or German made? Okay, so if it's American or German made, what would we do with those probabilities? We would just add them together, okay? So that was the simple or problems that we experienced before Christmas, or before Thanksgiving. And this is this is a symbol called union. And you told me a second ago we added those. And the reason we added, and we could just add them together like this, the probability of American plus the probability of British or whatever, the reason we could just add those together is because they were disjoint events. So odds tell the evens what it means to be a disjoint event. Let's remember back. Okay, so odds told the evens. Evens tell me, who's even right here? You are. Okay, so what does it mean to be disjoint?
To be disjoint means that the outcome of one doesn't affect the other.
So the outcome of one does not affect the other is independent definition. Okay, so not disjoint. Okay, so who's got the disjoint one? Sage, go. They cannot happen at the same time. Okay, so being an American made car and being a German made car are two separate events that cannot happen at the same time. They are disjoint. All right, so when they are disjoint, then we have got simple addition that we can do. Now, Abe kind of told us the other part. Say if I said, what's the probability of the first coin being a heads and the second coin being a heads? So I need those two things to happen at the same time. I mean, those two events to occur. And so that's an and problem. So notation wise, you have this upside down U, that's intersection. And I'm going to tell you how I remember that this upside down U is the and symbol. Is it? You've put a little line here. Guess what it looks like? Put an A. Yep, that's how I remember it. Okay, and whatever if you remember it. So if I said, what's the probability of getting a heads on the first coin toss and a heads on the second coin toss? Are those independent events? What makes those two independent events? What you get on one coin, what? Doesn't affect or change the probability of what you get on the second one. Okay, so that's what makes it independent, and that's what we had before Thanksgiving. So what did we simply do with those items? We multiplied them, okay? But now we're going to have situations this week that are not independent and situations that are not disjoint, okay? So let's go ahead and take a look at that. And so if you'll turn on over to page 20, then we're going to start with one technique to do conditional probabilities when events are a little more complicated. Okay, so I want you to read the first problem to yourself, and I think we're to the evens telling the odds. So the evens tell the odds if this problem is disjoint or not, and how you know. If the events in this problem are disjoint or not, and how you know. So read it and discuss. Okay, so evens told the odds. Grace, so the evens told the odds, so the odds tell me what you got. Perfect. It is not disjoint because we were told here that there are two students that are taking choir and band. So if I was visualizing this, there's overlap. Okay, so let's start there. All right. And then we'll have other things happening, so let's do that. So one thing that I want to do is give you a technique or a strategy that I think helps. You are going to always work from the inside to the outside. That is a technique that will help you with your Venn diagram. So in this first picture I drew, what do you think I mean? What's the quote unquote inside? Yeah, the middle right there of what they're both doing. And so what do I put there in the middle? This is the 2. And the reason it is imperative that you get that listed first is because the choir, what goes here in choir only? Ah, 18 take chorus, of which 2 are already in the choir circle. See, so therefore, this is 16. That's why that center has to be addressed first. Okay, so now, with that being said, 26 take band. So how many are in band only? 24. Okay, good. Now you got it. Okay, so there's that. So I want you then to actually, what I want to do is kind of at this point go over to the formula side because I'm going to tie it into the formula we're going to do, which is right. You don't have to go back, but I want to take a look at this formula right here. The probability of being in choir or band is being in choir plus being in band, taking away something here. So we're gonna. Oh wait, hold on a second. So let's go ahead and take a look at probability of being in choir or band when we have a Venn diagram. What would be, so all of this part here is the choir or band section. So it's choir or band or both. Okay. So how many are in choir based on the Venn diagram, not the formula yet? How many are in choir or band? 42. How'd you come up with that? So we added 16 plus 2 plus 24, and so that's how we got, because we had them all separated out, we get 42 are in choir or band. Now, read the question to this problem and answer it. What is that called if I want the other part? This is, I look at how I shortcutted this. I put C union B. That's choir or band. What's that called if I want the other part, the not of it? The what? Yay, good job. Complement. So I want the complement to that, which means I want to take the total, which if we were doing probabilities, it would be 100%. Or I could also think of it like I want to take the 50 students and subtract away the 42 in the middle. So what is the answer then to this? The 8 students are not in choir nor band. Okay, because it's the not. All right. Now, let's take a look at the formula way to do this piece here of choir or band. If I want to find out the probability of being in choir or, which is the union, band, and I don't have my picture drawn out, before Thanksgiving, what did we do? When the items are disjoint, what did we get to do with them? We just added the choir or the band together. Remember, like American or German, having an American or German car? So what is problematic if I added together the 18 in choir plus the 26 in band? You just did these two students how many times? Twice. Therefore, to do this completely correct, I formula-wise do the choir and the band, but take away anything that the intersection that got double counted. So that's the overlap of, and I'm going to abbreviate here, choir. And what symbol is it for and? It's that upside down, and band. So mathematically, how would this problem look from the formula standpoint? I would say what? Probability of choir? What? And I'm actually like not doing these in probabilities, I'm doing it in numbers, but 18 plus the 26 in band, but then take away the 2 that got double counted. So that's how I get 42 students. So that's the ones that are in choir or band like we did here. Okay, and then to finish the problem out, it asked for the not. So since it asked for the not part, we did the 50 minus the 42. All right, so I want you to take a look at problem number 2, and I want you to do it the 2 different ways. I want you to do it the Venn diagram way, and I want you to do it the formula way, and then we'll talk. Okay, so take a moment, do that. If you found the 95 that are on the outside, you did extra work. That's not what it asked for. It asked for how many students are involved in either band or sports. So it just asked for the 2 circles. And also, does the band and sports count as well? Does band and sport? Yes. So it's either or both. Okay. So that was 225. So then formula-wise, how would that look? What's the total band? The 85, total sports, the 200, and how much got double counted? The overlap of band and sports. So that's how you get that 225 students. Okay, very good. Now what I actually want to do is let's go ahead and just real quickly get a place where you can write this out real nicely. If you go to page 22, this is a problem. I want you to just write this out with the formula where we had kind of listed the formula second, so the probability. So do this problem again without looking at the Venn diagram for just the probability of being in choir or band, and then it asked for neither. Okay, so do the formula there and then do the neither. So fill in those notes. Okay, so I just wanted you to have that written down on your notes in a bigger space so you could write it all out. Okay, good. Done with that. Now, yes, ma'am. Oh, that's a good question. Dang it. I forgot that. Yeah, that's a wrong answer, what I have. Because it says, what's the probability? So how would I actually do this as a probability? 8 over the 50 total. Yeah. So then, dang, my bad. Okay, so you could leave it as fraction, decimal, percent. Didn't ask for how many. Good thing we fixed that, since this is a recording and it's going to be in there for, ever. Okay. All right. So let's go ahead and go on back and look at how problem 3 is different. 3 and 4. Look at 3. What's going on that it's different? Dogs, cats, and fish. 3 things. So guess what? No formula for that. So you're going to have to do a Venn diagram. So I want to let you do this, but it will be easier for you to check if your circles are drawn in the same order that mine are. So we got dogs, cats, and fish. So let me let you do that. And then we got 26 patrons. Okay, and I also have one fix. Okay, I want to fix this problem. So everybody, look right here. I want you to take out a word in the sentence that says, if no one has all 3 kinds of pets, take out the word no. I want it to say, if one patron has all 3 pets. So what's our technique? strategy. Start from the middle out. So that's where you should start. One patron has all 3 pets. Okay, so do that and now go out from there. So you see this entire football shaded area? How much does this football shaded area total? That football shaded area totals 4. Therefore, what's the section that's just the little dog and cat part? Yep. See this little part right here? Okay, let me make it clearer. Sorry, I didn't do that very good job pictorially. So we said this was 1, and this whole football is 4. Therefore, this is 3. Yep. Yep. Okay, so now finish it out from there. Okay, how we doing? Are you checking? So is this 6, 5? Okay. So there are some patrons that go to the vet that do not have a cat, a fish, or a dog. What does that mean? Why do they go to the vet? They have a gerbil, or they have a snake, or they have something, a lizard, whatever. Okay, they got something, an exotic pet. Okay. So how many patrons have none of those pets? Oh, how do we do that? So how many patrons have a dog or a cat or a fish? I'm going to add all those up. 8 plus 8 plus 2 plus 3 plus 1 plus 6 plus 0 plus 2. And I think that equals, I got a total of 22. I got 22 items in this whole circle section. So how many patrons have something else? So 4 patrons have something else. So it's kind of like the complement of that. Yeah, adding's a problem. Okay, so I want you to do this next one. I want to start it out for you so that it's easy for us to check. So get your things in the right place. Let's see here. French will be this one. Yes, ma'am. Okay, go. Let's see here. Because I got 3, 2, and 1. I have 6 already in the dog circle. So 6 plus 8 makes 14. Okay. All right. Okay, I'm going to let you work on this one. Remember your strategy. Work from the inside to the outside. Go. 5 want to take both French and Latin, and of those, 3 want to take Spanish as well. That's your start. 3 take all. All right, so here's a picture of the facts stated to me in the last couple sentences. Okay, these are the facts. Now, look at the French circle. How many unknowns are in the French circle? 2. How many unknowns are in the Spanish circle? 2. You got this one and this one. And the French was this one and this one. Okay, how many unknowns are in the Latin circle? Just this one right here. Therefore, Latin has only one unknown. That's where you have to start. Latin has the one with one unknown. So start there. Okay, so there we go. Okay. All right, questions there. I like these. These are puzzles. These are fun puzzles. This is okay. All right. So that's the Venn diagram technique. And so now, and we already did the formula technique for when we just have 2 events. Okay. So page 21 will be your first page of homework, and then let's go on to page 22. Okay, so go on to page 22 and let's finish learning. So we already did this top part of page 22, the not disjoint events and how you add them and subtract the overlap. But let's look at the bottom half of page 22. So we know what happens if the events are independent, like a coin flip and another coin flip. One event doesn't affect the other, the probability of the other. So we've got your half and then your half. If we want heads on 2 consecutive flips, we can just multiply those together. But that is not the case whenever they are not independent. So the general rule for this multiplication, and this actually is not quite right. I need to go like the probability of B times, but we're going to actually just take a look at what this means, okay? Starting with what's the heck does this vertical line mean? Okay? So what this vertical line says, and the way you would read it, is given that. So the way you would read this is you would say, what's the probability that A happens given that B is happening? So what's the probability that A is happening given that B is occurring? Okay. And so then, according to this formula, look at how this works. You put the entire probability of B on the bottom, all out of all the B's, because you're telling me B is happening. So I'm just looking at all the B's. So when I look at all the B's, then what I want on top is that overlap section, that intersection of A and B. This is where students typically make the mistake. Frequently, I get students wanting to just give me the probability of A over the probability of B. No, it's the overlap, the intersection of A and B on top of the B. So I want to do an example with the choir and the band problem from up above. And so let's do this problem. What is the probability that you are a choir student if I tell you you are, or if you tell me you are in band? So you tell me you're in band, and then I want to know what's the probability that you're in choir? Okay, given that. So what happens first? What goes on the bottom here? All of the probabilities of being in band. And I'm going to do these actually not in terms of probabilities, but in terms of the numbers. So the problem at the top of the page, what proportion were in band? 26, okay? So we're just going to do it as the number of items instead of the probability for right now. And then on top of this is not all the choir people. See, the problem that would happen, people would put 18 as the numerator. It's not 18. It's the what? Choir and band students. So you tell me you're in band. So you're in band, you're coming from that band circle. So you're coming from the 26 in this band circle. What is the probability that you are in choir now? So how many is the overlap here? 2, yeah, out of the total 26. So yeah, 1/13. So fraction, decimal, percent, answer's fine. Okay, so that's how that works. And again, people want to put 18 over 26. And it's not all the choir. You told me you're in band. So you have narrowed this down to the 26 in band. Now, of those 26, who are also in choir? Okay, let's go to this next page here and do these examples here. So we have boys and girls taking Spanish, French, and German, and they've got those. This one's actually listed in probabilities instead of number of students. So let's have you first do A. B and C is where it starts getting a little more involved. So just look at A and try that one. So this is saying out of all the students, what's the probability you are a boy enrolled in Spanish? So you are both a boy and in Spanish. So I want that intersection of boy and Spanish. And what is that? That's your 20%. Okay? All right. But from there on out, the facts change because we have something that is a known fact. It's not just pulling from all students. B says, what's the probability that a boy is enrolled in Spanish? What is a fact that we know? Yes. What is the probability that a boy is enrolled in Spanish? So that is saying this. What's the probability, given that this is a fact I know, you are a boy. Given that you are a boy, what's the probability that you're a boy in Spanish? See? So that's how this is different. It's based on the fact that you're a boy. Now I'm going to write extra steps here and then I'll show you what you have to show. Probability of boy, and then what goes on top is the Spanish and boy. Okay. So what's our total proportion of boys in the sample? 0.4, but what's the intersection of the Spanish boys? Okay. So you can write that however you want, 50%, decimal, fraction, whatever. Okay. Work-wise, you have to show, at the very minimum, this and this, and, a nicely reduced fraction would be better than a decimal in a fraction form. So read C. What is the fact? You are a Spanish student. So you are given and told that you are a Spanish student. Okay? So I'll show you what the minimum work is. Oh, well, there's minimum work, I guess, but that's very awkward. So at some point I would probably change that into something more normal. A decimal in a fraction is probably not ideal. It's weird. Okay? All right. So no kidding, this this notation is required. Okay? That's a required item. You are giving statistical notation, and that's one of the things you're learning, okay? And then, of course, the answer. All right, so I want you to go down and try these ones with the deck of cards. So try that there. So there, you can check that. Okay. And that's the very minimum that you have to include. Okay. Now, okay, and so then your homework that you're going to do, of course, is you're going to go back and do that page 21 on Venn diagrams, and then you'll do these pages 24 to 26, which puts that all together. So there you go.